In this problem, we're asked to consider the curve y equals 4x to the 3 halves from the origin to the point 1, 4. So a rough sketch, real rough, of this curve is we want to know it starts from 0, 0, it increases to 1, 4, and we're interested in what is the length of this curve. And so we know that y prime is equal to 6x to the 1/2. And this means that the length of the curve must be equal to the integral from 0 to 1, because everything is in terms of x, so our x values go from 0 to 1, of the square root of 1 plus 6x to the 1/2 squared dx. And if I continue to work with that integral, simplifying it down, this changes to 0 to 1 of the square root of 1 plus 36x dx. And I know for myself, I find it easier to think about this in exponential form. So 1 plus 36x to the 1/2 dx. What I see when I integrate this is this must have come from 1 plus 36x to the 3/2 by the power rule, and since there's no coefficient out front, there must have been a 2/3 here that when multiplied by 3/2 ended up being 1. I also see that by the chain rule I would have taken the derivative of the inside, which is 36, so that must have also been divided out. So this is my original function by the chain rule. Really just reversing the chain rule. This simplifies down to 1/54 times 1 plus 36x to the 3/2, and we need to evaluate this. From 0 to 1. When I plug 1 in, it's kind of an ugly number. It ends up being 1 over 54, and that's going to be multiplied by 37 to the 3/2 minus 1. And when I evaluate this in a calculator, I get 4.149 units, about. Right? We're always rounding to 3 decimal places. So the length of the curve is approximately 4.149.